23. Okay. So first we go with the yesterday's class. So for what we have learned yesterday. So after that we will come to today's class. So yesterday we have learned about the fact table, right? So what is fact? Fact is which is contains facts and measures, right? Facts and measures. Okay. And facts is nothing but what, as I said, like these are the dimension keys. Okay. So how the dimension keys will be available in the fact table, we'll see. And coming to the types of facts, what are the types of facts? Anyone can respond, right? So if you respond only, you will see, fine, okay, added to fact. So if you respond something like that, I can understand you guys are understood something, right? So if you didn't respond means so I will be in confused. Yep, fine. Additive, semi-additive, additive, semi-additive, and non-additive. Additive, semi-additive, and non-additive. So when you are going for any concept for the explanation, right? Go with an example, okay? Even in interview, if you are going with if you someone asks you like what are the types of facts, and you might have said like this is additive, semi-additive, non-additive. But if you go with an example, right? So they will understand a clear picture, right? So you have a concept something which is additive or semi-additive, non-additive. They will understand that something like that. Okay. So go with an example any time. Okay. So additive means what I said, like I have taken one example, right, yesterday. That is called, it's a product table or store table, right? Columns I have taken, there is what, there is a fact, and that table is, I will call it as a store table, fact store. Okay. Because it's a fact table, right? Fact store, and it has a store key, and it has a product key, and it has transaction key, transaction date key. Okay. And also as part of the fact table, it should have a revenue. Okay. It should have a measure amount or something measures, right? So that is why I call it as revenue. Okay. So these are the what columns available in the fact table. Okay. I have taken one example S1 and the P1, and also the date key will be like today is 11th I have taken, right? So 11th 09/2023. Okay, you will have the date like this as well. Okay, the format will be like this. Okay, so 100, and also S2, and I will take this for as 09/2023. Okay, and also this is the revenue amount. And coming to the S3, this is the P3, it's a product key, and 13/09/2023. And the amount is 300. Like this fact table will have all the columns data, right? Store key, product key, and transaction date key, and revenue. So from this fact table, if you want to derive something like that in a particular store on S1, what is the product it sale, and on a particular this product on a particular date, what is the revenues generated. Okay, these type of questions, so these type of analysis we can do by using this fact table. And for this analysis, we are using all the columns of the table that is known as a additive fact. Okay, and also coming to the semi-additive, I have taken one example of the account table. where it has a account table, account number, account account number and date and account balance and profit margin. These are the columns which it is available to to derive something like that, the account current balance. Okay, account current balance on a particular day, you will have to use only date key and account key and as well as the current balance, but you never mind about the profit margin to derive something like that, right? That is called, we are summing up some of the columns in a fact table to derive something that is known as a semi-additive. Okay, so coming to the non-additive, so profit margin is a single column which is used to derive something like that, bank's profit margin. Okay, that is known as a non-additive. So we are summing up with only one column. We are not summing up with all the other columns. We are not using only single column from the table. We are deriving something that is known as a non-additive. Okay, so based on this additive, non-additive, and semi-additive, so we can derive the fact tables. So we can divide the fact tables into two types. Our fact tables are divided into two types. That is called cumulative fact table and snapshot fact table. Okay, so cumulative fact table is nothing but what? Cumulative fact table, it tells the what has happened over a period of time, right? If in a particular year, if you take it from transaction date 11/9/2022 to 2023, what has happened, right? By using all the columns, you can derive that thing that is called as a cumulative fact table. Okay. And also, what is snapshot fact table? Snapshot fact table is nothing but, so where we are deriving something where we are saying the particular a particular product state in an instance of time. Okay, that is called as a snapshot fact table. Examples, semi-additive, non-additive. Okay, fine. So these are the fact tables. So this is one of the example of the fact table. Now we are moving into the dimension tables. What is dimension tables? What are dimension? What dimensions will have? Any idea on dimensions? Descriptive data. Yes. So descriptive data is nothing but, right? So if you take an example of this store key and yes, fine, good. Okay, I will take one example. I will take this fact table is one of the example, and I will take from the fact table from the store keys, right? So how the fact and dimensions will have a relation that we will see now. Then after that, we will move into the different type of dimension tables. Okay. So suppose I take a one of the example of the, this is the dim store. Dim store is the table and it has a store key. Okay, and also I think it should have store key, and this is what product key. Okay, forget about the spelling C and red marks in this here. Just understand the concept. Okay, sometimes I will not write the correct sentence, correct spellings. Okay, so there is product key will not be here. Sorry, and it will be like store name or branch name. Okay, and the address of the store. Okay, and also contact number. Okay, contact number of the store, something like this have a S1 and store. Suppose in Hyderabad we have a KP, KPH, KPHB one branch, and address is like it is a Hyderabad, and also the number is something like this. Okay, and for the S2 we will have a one more branch in high-tech city. Okay, and it is has like it is the location address is same Hyderabad and number is something. Okay, and same thing S3, and it is in something like okay, 40. Okay, and we'll have like it is Hyderabad and location is the number is different. Okay, so this is like this. The dimension tables will have a And a particular store, see, and for the particular store, we will have all the descriptive data, whatever this store is, store name and the address and contact number, something like that. And same way, I will have one more dimension that is called as dim product. Remember, see, every dimension will have a prefix of dim. Okay, so every dimension will have a prefix of dim, and every fact will have a prefix of fact. Okay, so suppose I will take this product table. Okay, so first thing is a product key. Okay, and also here one more thing we have to have like this is here in general in data. Okay, data warehouse. Now we will have one more column here that is store ID. Okay, store ID that is called ID is nothing but it is 102, sorry 101 and 102 something like that. I will assign to for the store ID 103. Okay, and product key and this is product ID and also product name and also product name and the price will not be available. Okay, for the product, price will be the measure and that will be available in the fact table. Okay, so product to manufacturing like product like produced by something like manufactured by, right? Manufactured by something, the details are there. Okay, so this is about the product. Okay, so suppose the product key is like what we have mentioned is P1 and the product ID is 201 and the product name some, okay, some X, okay, some X I will name and manufactured by something like some private limited. Okay, we don't know like just for an example. Okay, it is a P2 and the 202 is the product ID and Y is the product name and something less a limited. Okay, so something private limited or something. Okay, fine. So if you see these tables, right? So this is the fact table and these are the dimension tables. If you find out like, so this product key, store key, these are the keys available in the fact table. In general, whatever the products, ETL projects we are working, right? So the whatever the keys available in the dimension tables, those keys will be available in the fact table. These are known as a facts. Okay, these are known as a facts. It is never going to be changed, right? So in same thing, just like the transaction date key, also we will have a dim date table. Okay, dim date table. In a dim date table, we will have a date of day in day, month, week, year, something like that. Columns that date will be, and it will have a date key or transaction date key will be have that has a column so that if you want to derive something like on a particular store and its store ID and it wants to store name and the address and contact number on the particular store and with all the descriptive data and the same time on a particular product in a store like P1, what is the product ID and what is product name and who is manufactured this. If you want to know these details, you have to join the fact table with the different dimension tables with using the keys which are available in the fact table. So this is the relation which is having the between the fact and dimension. By looking at the tables, you are observed, right? So this is relation. This has a relation between the fact and dimension by using the keys. Okay, by using the keys. And also, if you see whatever like when you done a ETL process, generally we done with the ETL process like we are loading the data from source to staging to target. Target is nothing but data warehouse. So while you perform a ETL process, which table load first? Which table load first? According to this, according to the relation between the fact and dimensions, which so assume that which table loads first?
fact table.
No, that is not correct. Okay. So always when the ETL process is done, right? So according to the data warehouse, dimensional table loads first. Okay. So then after that, see, fact table should have all the keys. Okay, store key, and product key, and transaction key. So where these store keys will be acquired from the fact table, we can't load if there is a no dimension. If suppose store dimension store dim store is not stored, dim store is loaded, and it has a store key. Okay, in a fact table. But if it is not loaded, okay, the data is not available in the dim store. Well, so then the fact will have will have the store key data, no, right? So that is why in a data warehouse process, always remember dimension tables loads first, all the descriptive data loads first, then after the fact table will be loaded. Okay, clear? So this is the one of interview question someone will ask you, right? So in the process of data warehouse data load, so from both the like fact and dimension tables, which loads first? Okay, this is the process. Like as per the process, the fact table will contain the keys, dimension keys in the fact table. That is why the dimension table loads first, and after that, whatever the keys available in the dimension table, those will be load here in the fact table. Clear? Okay. So now we will look into the types of dimension tables. Yesterday I spoke about the confirmed dimension, right? Confirmed dimension, and also what is degenerated dimension, and also junk dimension, and role playing dimension. Okay, junk, role playing, degenerated, and slowly changing dimension, SCD. It is called as a SCD. Okay, slowly changing dimension and fastly changing dimension. Fastly changing dimension. So now we'll see what is confirmed dimension. Confirmed dimension. A dimension which will have a relation between the multiple fact tables, even though it has a relation between the multiple fact tables, the what is that the name, like the details of the compound dimensions, it will not change. The details of the compound dimension, the consistency of dimension will not be changed. Okay, compound dimension is nothing but dimension will have relation between multiple fact tables, even though it will not be, it will not have any change in its definition. Okay, suppose we will take an example. Suppose we will take an example of customer table, dim customer. Okay, dim customer table, and this customer will, okay, this customer will have a table data like dim table. How it looks like? What will be data in a dimension table? Dim customer.
Customer name, contact number,
See,
address.
remember, first thing, whenever you consider any table, right? So there will be a unique identification value. Okay. So always remember we have to, we should have, if any table, like even in a relational database, there will be a primary key like product ID, customer ID, something like that. Okay. So, but in data warehouse, we will have keys. Okay. Why we have a keys? I mean, we know about the surrogate key. This time we will spoke about the keys. Okay. But remember, as of now, for any dimension table, we will have a one key that is a unique value. Okay. So the first column will be customer key. Okay. And also the next column will be customer ID. Okay. And all then customer name will become customer name. Okay. And after that, whatever the address, phone number, something like that. Okay. So these are the columns will be available in the customer. This dim customer will have a relation in the between the multiple fact tables. Suppose this is the fact sale, fact sale. Okay, I will explain a pain so that you will understand better. So this is the customer table. Okay, and it has the fact sale and fact product. Okay, and the other fact transaction. Okay, something like that. Okay, this customer table will have a relation between the these multiple fact tables like this. So what is this name? This is the dim customer dimension customer table, and it is the fact cell. Okay, generally the fact tables names with the I said like a fact will be prefix, right? Then after that it is generally known as a application. Suppose it is a Gmail application, something like that. If you imagine, so it's like Gmail, and then after that, what is it? Is a transactional. If you think like this is the transactional Gmail transactional fact Gmail transactional sales like this. Okay, the naming conventions will be like this only for the fact table. Okay, so first fact, then after that the which application it is going to be used. Okay, and that application, it is a if it is a transaction oriented, then it will be like transaction details, something like premiums or return premiums, estimated premiums, something like that, right? Then it will be named as a transaction. Then after that, for which transaction, the names like sales, product, something like that. The names will be like this for the fact table. Okay. It is like fact. If you go with the DMOD, right? DMOD application and transactional product. This is one more product. So one more fact table. But whenever you change, see in this diagram, so this customer will have a this customer will associate with the fact table of sales and fact table of product with even though the customer definition is going to be changed. No, right? The customer name is same and customer ID will be same and customer key will be same and the address and phone number will be always same. But even it has a multiple relational between the multiple fact tables. This customer dim customer is known as a confirmed dimension. Okay, so the dimension can have a relation between the multiple fact tables, even though the definition of the dimension tables will not change. That is known as a dimension customer. Okay, so that is known as a confirmed dimension. Example, one more example there is like that is a date, dim date. Okay, so date will have a columns like day, week, month, year. Okay, in this case, so the dim date will be associated with the multiple fact tables, whether it is sale, whether it is product sale, or whether it is other like insurance sale, or whether it is a surety sales. Okay, surety insurance sales. Okay, so whatever. So if it is assigned to, it is have a relation between the multiple fact tables. Even the definition like year will not be changed, day will not be changed, week will not be changed, and month will not be changed, right? So that is known as it. The best example of confirmed dimension is the like dim date. Okay, dim date and customer dim. Okay, somewhere like it will have some cross join, so there might be some changes in the customer dim customer, but the best example of the confirmed dimension is the dim date dimensional table. Clear? That is about the confirmed dimension, and next is degenerated dimension. Okay, degenerated is nothing but the name itself is saying like something it is generating from itself, right? Okay, so for example, like if we have a one fact table, in that fact table we will have one column. That column itself is acting like a dimensional key. Okay, dimensional data. Okay, so because of and with that dimensional column, we can analyze something. That is how it is known as a degenerated dimension. Suppose if you take a fact product, fact product is a table. Okay, this product, fact product will have a columns like product key, product key, and we'll have a product quantity. Directly I'm saying quantity and price. Okay, here we will have a invoice number. Okay, invoice number. So product key will be like 101 and quantity will be like around 10, something like that, and price will be something 4,000 or something. Okay, invoice number will be 11223344 something like this. Okay, and the product is 02, and that it has a some 30 quantity. Suppose like 10,000 is the data, and also the invoice number is something like this. Okay, in this table, if you see, if you identify the invoice number, right, this thing, so this is act as a dimensional case. So based on the invoice numbers, right, based on the invoice numbers, so you can identify on a particular day how many products are sold, right? How many products are sold? You can derive this thing by using this invoice number within the fact table. So that's why this invoice number is known as a degenerated dimension. Okay, this is the dimension key is available in the fact table, but it is so the but this is a measure, like this is a fact. The invoice number is a fact. Invoice number will not change, right? Invoice number with if you buy any product, even though the invoice number is once the invoice number is generated, right, so it will not assign to any other product. So that means it's a fact, so it should be available in the fact table. But by using this also, we are deriving something like how many products are sold today. Okay, that we can derive. That means it is acting as a dimension, so that this is known as a degenerated dimension. Got it? Okay, so this is confirmed and degenerated dimensions we have seen. And now we will see junk dimension. Okay, what is junk dimension?
Excuse
Suppose,
me.
yeah,
Here quantity is a measure or a fact?
quantity is a measure, right?
Yes, but here, as you said,
Mhm.
in dimensional tables,
Okay,
we'll have only facts, right? Not measures. It's not
this is a
club of
fact
like.
table. This is a fact table. If you
Okay.
see the name of the table, fact product.
Okay.
Okay,
Okay.
in fact table, we will have a dimension. Like
Okay. Okay.
so
Okay.
it is acting as a dimension.
Okay. Okay.
Okay, so it
Okay.
is not a dimension table, it is a fact table. Fine.
Okay.
Okay, so coming to the junk dimension. Okay, so junk dimension is nothing but where we'll combine the two dimensions. Okay, so as we see, like we will have a dimensional keys in a fact table, right? So for each dimension table, we will have one key, and that key will be available in the fact table. But when you are going to derive something like, if you derive something, if you derive something like product times two between the fact table, so the giants will be like with this fact table, you have to join the dim product and dim store. Like this, if there is a 100 dimension tables, you have to join the 100 dimensional tables with the fact table. So reducing the having the number of keys in a fact table will improve the performance of our that analysis process, right? So in that case, there will be some tables where the tables can be combined, the tables can be denormalized. Okay, and we will have one key in a fact table by for the two tables, that is known as a junk dimension. So we are by combining the two tables, we will maintain one junk id or one junk key. That key will be available in the fact table so that we reduce the having the number of keys in a fact table, and we will improve the performance of our analysis. So we'll take one example, then you will have a clear picture. Okay. So suppose there is a one dimension table that is dimensional marriage. Dimensional marriage is the table, and it has the column like three columns. It is a marriage key, okay, and marriage ID, and description. Okay, marriage description. Okay, fine. Marriage description. So now the marriage key will be something like that 101, and ID will be like 201, and marriage is not description is nothing but married, right? And 102, and the marriage ID is like 202. Okay, and it is unmarried. There will be two things, right? The status of the marriage description or marriage status, we can say. Okay, the status of the candidate can be married or unmarried. Okay, these are the two columns will be available. Three columns will be available in a dim marriage, and this is the data which looks like. Okay, and also dim gender. I'm taking these two columns. Okay, dim gender. So two tables, and dim gender will have a columns like gender key. Okay, and gender ID, and also gender description, something like this. Okay, and the key will be like 301, and ID will be 401 something, and gender will be male, and other one is 302 and 402, and the other thing is female. Okay, so these are the two tables. Okay, we'll see like what is the probability of having a one customer details in a one customer details, and whether he might be a married, and he might be a male, and he might be a married and might be a female, and same thing, he might be unmarried, he might be a male. The probability of customer status in this marriage and gender description, so there will be like one married male and married female. Okay, unmarried female, unmarried female. There will be four type of records will be available in the tables, dimension tables, right? So what we can do, we can combine these two tables, and we will have a one key in a fact table, right? So instead of having marriage key and gender key in a fact table, we can combine this table into like this dim gender gender marriage, like this, and here we will have a keys like this, columns will be like this. Okay, and also the key is like this is a gender and marriage key, or we can have a this is called a gen key. Okay, gen key. Okay, so okay, marriage key, gender and marriage key, and also I call as ID and the description. Sorry, gender description, DSC, and also marriage description. Suppose what is the key? Okay, the key will be like we can have something like other than the which have in a about tables. Okay, 501. Okay, 501 ID will be 601, and the probability of like a male, the gender description can be male. He is a married. Okay, and also I will have a one more like 502, and the data will be like this 602, and you can also mail, right? Is a unmatched. And same thing, we will have a two more records in this table, Okay, so 503 and it has like 603 and just female and they are also married, right? Female and married. And also 104, so 504 and 604 and female. And the thing is that and married. Okay, like this. So instead of having these two keys, okay, instead of having these two keys in a fact table, we can have only one key to get this data of a particular customer. Okay, whether if the first customer is a male and whether he is married or unmarried, and if the customer is female, whether he is married or unmarried. So like this, we will have this only one key in a fact table. This key is known as a junk key, and this dimension table is known as a junk dimension. Okay, so junk dimension will provide us the having a reducing the number of keys in a fact table to improve the performance of analysis. Clear? Clear about the junk dimension? Okay. So now we'll go on to see role playing dimension. Getting right? Or any confusions?
I have a doubt here.
Okay.
Uh, as you said that junk table is to combine both the here in the example like gender and marriage table, but
Okay.
what is the common key here? We are combining the data, just we are combining the two tables, that's it, right? Or do
See, here in a fact table, for each dimension, we will have one column. If you identify, if you see in this example, right?
hmm.
So just a minute, I will show. Yeah, for dim store, we have one column. Okay, from dim product, we have one column. Like this, for every dimension, we will have one column, right? So as part of the gen dimension, but the examples we taken, right? One is the gender and one is the marriage. For
Hmm.
these two dimension, we will have two columns in a fact table, right? So to reducing the number of columns in a one table, particular table is also we are utilizing the memory in a correct optimum way, right?
Yes.
Also, you if you are going to join, if you are going to join with the two tables, right? You have to join fact table with the one time with the marriage key and other time with the gender. But here is that is not the case. Okay, you have to join the fact table with only one key, that is gender marriage key, and this column only one. This column will be available in the fact table. And here we are using the correct way of memory of database. We are having only one key in a fact table, and also while executing the query, so instead of joining the two keys, and we are joining with the one key, so that the performance time will be reduced, right?
Yes.
So that is how the use of the Jeng dimension.
Hmm.
Got it?
Yeah.
Okay. Any other doubts? Anyone? Fine. So role playing dimension. Role playing dimension is nothing but like where we have a dimensional table and we will have one dimensional key in a dimensional table. That key will be having a relation between the multiple keys in a single fact table. Okay, multiple keys in a single fact table. That means one dimensional key is playing a different roles in a fact table. That is called role playing dimension. Suppose I will take an example. This is a role playing dimension, or we can call it as a team date is the dimension table where we have a columns like here the columns will be like this. Okay, date key. Okay, and also the date key will have a that day is the one column and week is the one column and month is the one column, year is the one column. Okay, these are the columns available in this dim table, and we'll have a one fact table that is called fact. Suppose take an Amazon fact. Okay, Amazon sales fact. Okay, so here we will have a columns like order date, order date, okay, order date key, and shipping date key, and delivery date. Okay, so for this date keys, we will have this from this dimension, we'll have a relation between the only from the date key to ship date key, order date key, and also we'll have a relation with the delivery date. Okay, so the date will be different. Okay, but if you want to get that particular date, the relation between the dimensional table and fact table between we happen between the only with the date key. So in a particular dimension, this dimensional key is acting with the is having a relation between the multiple keys in a fact table, and it is playing a role of multiple keys in a fact table that is known as a role playing dimension. Okay, got it? Okay, so if some product is ordered, so you want to know the date, order date. Okay, it is going to be combined with it is going to be joined with the date key, and it will pick some date, or it's some we pick some week, it picks some month, it's pick some year. Okay, and but the relation between the dimensional fact table will be only with the one key, that is a date key. Even it is a shipping date also, it will be joined with the date key, and it will pick the one which week you have order you have that product is shipped. Okay, that details will be analyzed based on the relation between the date key and order key and ship date key or deliver date key. Okay, so this is known as a role playing dimension. Got it? Fine. Okay, so we have seen till now like confirm dimension, degenerated dimension, and junk dimension, and role playing dimension, right? Till here we have seen. So we'll see what is a series. Okay, slowly changing dimension. Before that, we will go before to go this S series, slowly changing dimension. Okay, so what is slowly changing? And before going to slowly changing, we will understand one concept like series. Change data capture. Okay, change data capture. What is change data capture? Okay, suppose if you take an example of an employee table. Suppose this is an employee table, and this employee table will have a, so assume that this is a dim employee. Okay, and the columns will be employee key, EMP ID, EMP name, and location. Okay, and also we'll have a phone number as well. Employee key will be like 101, ID will be something like 1022, some FA, something like that. Okay, name will be like Nareen. Okay, and location will be Hyderabad, and phone number will be something. Suppose this employee is a worker like around like 5 years in Hyderabad location. After that, he promoted as a manager, and he has to shift to the other location. That means Bangalore or somewhere else. Okay, so that means this data in application level, if you want to identify after the promotion, he got the promotion, he shifted it to the Bangalore. If you want to identify where this employee is currently working, which in which location this employee is currently working. So to that, you have to know the location column data. At the same time, he has shifted to Bangalore, right? So this data should be updated, or we have to maintain a some other columns with the same data, some other record or other record will be here, the same data. Okay, so here the data will be Bangalore. But by looking at this, which one is current one? Do you know? No, right? We can't identify which one is current one because without the date or some other things, right? So, but thing is that in a change data capture, the concept is whatever the record, whatever the dimensional descriptive data, whatever the descriptive data has a change, right? That should be captured in the dimensional table. Okay, in a data warehouse. Then only we can identify something, right? Then only we can identify, we can or we can analyze something from the table. Okay, based on the capturing the data, based on the the way we are capturing the change data, the way based on that, the SCD types, the slowly changing dimensions are type, three type, that is type 1, type 2, type 3. Also, there is a type 4 and type 6, but those are not in utilization of the developing the data warehouse, even though we will see those types because in case of an interview, if anyone asks you, you can answer those things. Okay, this is what based on the capturing the change data, based on the capturing the change data, the slowly changing dimensions are divided into types, different types. Those types are known as a say type 1, type 2, type 3. So this is how what is change data capture. Okay. Somehow like we are not going to have a separate record here. Okay. We are not going to have, only we are updating this location. That is fine, right? We can have like only one record. So we will say like, okay, this employee is currently in a bank. But if someone will ask you like this employee is resigned, okay, this employee is resigned, and you someone came to for the background check, and if they ask like where he worked previously, so will they answer? No, without the data in the database, how can they answer, right? So they don't know the person, this person personally, right? So if there is a 1-2%, okay, fine. But in an organization, there will be lack of persons, lack of employees are there, lakhs of employees are there, so we can't identify. So if this data is stored, so if you are maintaining the history as well as current record, that will be a one type of storage dimension. If you are maintaining only current data, that is known as a one type of dimensional. And also there is a possibility less we will maintain the current and like previous one, not previous to previous one. That is also known as a one type of storage changing dimension. Okay, this is very important concept, storage changing dimension. Whatever we are working in ETL process, right? So in ETL process, so how generally every company, every data warehouse while developing a data warehouse, they follow the only type 2. Okay, so we have to know how the data will be stored in the type 2, and also what are the scenarios we have to test while loading the data. Those things we have to identify so that you have to be a clear picture on this slowly changing dimension. Okay, so that thing we will see tomorrow. Okay, so we'll have a examples and how data will be stored and how the current and history data will be identified. Those things we will see tomorrow. And after that, we will see about the fastly changing dimension. Fastly changing dimension. So what is fastly changing dimension is nothing but like here the data will be stored like the after 5 years, like after the 5 years, the location is changed for the employee. There will be frequently changed descriptive column. Okay, in somehow like in some cases, there will be frequently like in 1 hour or 2 hours or 3 hours, something like that. Within the day, there will be a lot of changes for the particular descriptive columns. In that case, how that data warehouse will be developed, that we will see in a fastly changing dimension. Clear? Fine.
Yes.
Okay. So this is what today's class. Okay, we'll catch up tomorrow. If you have any doubts, let me know. Otherwise, we will close this class today. Fine.
Yeah, I
Okay.
have a doubt actually.
Yeah, tell me.
In role playing is there, right?
Yes.
Is it restricted for a single fact table or any number of?
It is actually role-playing concept is like within the domain, which is the one fact table. Okay. So
Okay.
this can be have a relation with within the other fact table also. That is also fine. But the thing is that the
Hmm.
concept is that within the same fact table, we will have a relation between the multiple keys.
Yeah, that is what like. Okay.
Yes. Yeah. If you have a one more fact table and there also you can have a same date key, right?
Yeah.
If you go with the Flipkart fact table. Okay. There also we will have the same keys and the same date key will be work with that.
Then we can use it role playing, right?
Yes, that is also good.
Okay.
Okay. The concept is to one key is playing should play multiple roles in a fact table.
Multiple roles. Yes.
Yes. Okay.
Okay.
Okay then. Okay. Have a nice day, bye, guys. Bye.